Welcome to our channel. Today, we're diving into the mind-bending world of physics to explore some of the strangest paradoxes that have puzzled scientists for years. You know, the kind of stuff that makes you go, wait, what? And then stare intensely at your reflection trying to figure it all out. These aren't just brain teasers or philosophical curiosities. These are real puzzles that expose the limits of our understanding of the universe. Get ready to have your mind blown. So, what exactly is a paradox? It's not just something your weird uncle says at Thanksgiving. It's a statement that seems to contradict itself, yet might actually be true. Think about that for a second. How can something be true and false at the same time? That's the beauty of paradoxes. They force us to confront the limits of logic and intuition. In physics, paradoxes often pop up when we're dealing with the really big stuff, like the entire universe, or the really small stuff, like the quantum world. These are the realms where our everyday experience breaks down, and the rules of the game change. Paradoxes are like flashing neon signs pointing to where our current theories need some serious rethinking. They highlight gaps in our knowledge and push us to develop new and more profound ways of understanding the universe. So, buckle up, because we're about to embark on a journey to the frontiers of physics, where reality itself seems to come undone. Let's start with a classic, the twin paradox. Imagine identical twins. Let's call them Alice and Bob. Bob, the adventurous one, hops on a spaceship and blasts off at close to the speed of light. Alice, the homebody, stays on Earth. Now, here's where things get weird. Einstein's theory of special relativity tells us that time is relative. It's not a constant, ticking away at the same rate for everyone everywhere. Time is affected by speed and gravity. The faster you move, the slower time passes for you relative to someone standing still. So Bob, zooming through space at near light speed, will experience time passing slower than Alice back on Earth. When Bob returns home, he'll find that he's aged less than Alice. This isn't just some sci-fi mumbo-jumbo, it's a real phenomenon that's been experimentally verified. But wait, how can that be? Shouldn't it be from Bob's perspective that Alice is the one moving fast and therefore aging slower? That's the paradox. The resolution lies in the fact that Bob doesn't travel at a constant speed throughout his journey. He has to accelerate to reach near light speed and then decelerate to return to Earth. These changes in velocity break the symmetry of the situation, making Bob's reference frame different from Alice's. Chapter 3. Now let's dive into the quantum realm with Schrödinger's cat, perhaps the most famous paradox in all of physics. This thought experiment was devised by Erwin Schrödinger to illustrate the absurdity of a concept in quantum mechanics known as superposition. Imagine a cat sealed inside a box with a device that has a 50% chance of releasing a lethal poison within an hour. Here's the catch. According to quantum mechanics, until we open the box and observe the cat, it exists in a superposition of states, both alive and dead at the same time. It's not that the cat is either alive or dead and we just don't know which. No, the cat is in a blurry, undefined state of being, both possibilities simultaneously. This is because in the quantum world, particles don't have definite properties until they are measured. It's the act of observation that forces the particle to choose a state. Schrödinger's cat highlights the bizarre nature of the quantum world and the challenges in reconciling it with our everyday experience. It seems absurd that a cat could be both alive and dead, but that's how the quantum world seems to work. Chapter 4. Who doesn't love a good time travel paradox? The grandfather paradox is a classic. It throws a wrench into the very idea of time travel, and not the fun kind of wrench. Imagine you build a time machine, travel back to the past, and for whatever reason prevent your grandfather from meeting your grandmother. Seems simple enough, right? But hold on. If your grandfather never met your grandmother, then one of your parents would never have been born, and consequently, neither would you. But if you were never born, how could you have traveled back in time to erase your own existence in the first place? That's the paradox. It creates a logical loop that seems to defy the basic rules of cause and effect. There are a few possible solutions to this paradox. One is the idea of parallel universes. Perhaps when you travel back in time, you're not actually changing your own past, but rather creating a new, branching timeline. Another solution is the Novikov conservation conjecture, which suggests that if time travel is possible, the laws of physics would somehow conspire to prevent any paradoxes from happening. In other words, you might try to kill your grandfather, but something would always happen to prevent you from succeeding. Chapter 5. Let's wrap things up with a paradox that takes us from the quantum realm to the cosmic scale, the Fermi paradox. This one keeps astronomers up at night. The universe is unimaginably vast and ancient, Billions of stars are out there, many much older than our own sun. Given enough time and the right conditions, it seems highly probable that life, even intelligent life, should have arisen elsewhere in the cosmos. So where is everybody? Why haven't we encountered any signs of alien civilizations? This is the question posed by physicist Enrico Fermi. It seems paradoxical that with such a high probability of extraterrestrial life, we haven't found a single shred of evidence. There are many proposed solutions to the Fermi paradox, each more mind-boggling than the last. Perhaps advanced civilizations have a limited lifespan and tend to self-destruct before reaching out to the stars. Or maybe they're out there, but they choose to remain hidden, observing us from the shadows like cosmic gardeners tending to their galactic flower bed. Or, and this is a bit unsettling, perhaps we are alone in the observable universe, a lonely island of life in a vast and indifferent cosmic ocean. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mind-bending content. Let us know in the comments which paradox blew your mind the most. From the strange nature of time to the mysteries of quantum mechanics and the vastness of the cosmos, paradoxes challenge us to question what we think we know about reality. They remind us that the universe is full of surprises, and the more we learn, the more we realize how much we don't know. So keep exploring, keep asking questions, and never be afraid to embrace the unknown.